So what makes the denominator 0 or the limit is equal to positive or negative infinity? That's your vertical asymptote. Okay. Then we did horizontal asymptotes. Which I'm going to abbreviate HA. Those are the limits as x goes to positive and negative infinity, sort of tied into slant as well of your function. So basically it's saying, what is the function doing as x gets really, really big or x gets really, really small, negative infinity? Now there's a few different ones for this that we're going to have to talk about, but we'll look at rational functions first. This is the kind you did in grade 12 and the kind we did at the beginning of this course. So if you had a function like this, actually change that to x plus 1 in the numerator. There, that's better. Do you remember how you solved this? There's two ways. I showed you a shortcut and I showed you the proper mathematical way. So here's the proper math way, and then I'll show you the shortcut again. We go, okay, what is the limit as x goes to infinity of this function? So you look for the highest exponent. What's the highest exponent? 2. So you multiply the top and the bottom by 1 over x squared. Do you remember this from the limits unit, the very first unit? So when you multiply the top, I'm going to get x over x squared, which is 1 over, I should write it as a limit. You get 1 over x plus 1 over x squared over 1. Does everybody see how I got that? Okay. And why am I saying 0? It's going to go to infinity. There you go. Okay. So then you plug in infinity. What's 1 over infinity? So I end up with 0 plus 0 over 1, which is 0 over 1, which is 0. That's your horizontal asymptote. So this is your HA. That's the technically correct way to do it. In math 12, we said, remember we had those 3 rules? And the rules were the denominator degree is greater than the numerator degree, then your HA is y equals 0. You remember that? That's the shortcut. What I did is the proper way of how to solve it. I don't care. Okay? I am fine if you use this. We've already done this. I put that on the very first test, the limits test. So we don't need to show that again. If you can just look at that and tell me what the HA is, I'm happy. Okay? B. Now I'm just going to give you the rules that we learned in grade 12, okay? Because you can go through the same process, but it's kind of just the same thing over again. If the numerator degree equals the denominator, degree, then your HA is what? All right, let's look at it. Here's my function. So there's my function. The degrees of the numerator and the denominator are the same. So what's the horizontal asymptote? It's not 1. It's the leading coefficients, 3 over 2. All right? So in this case, your HA will be y is equal to 3 over 2. There's a sort of a cheater way to do it. Do you want to know the cheater way? I don't want to say cheater. Quick way to do it. What you're doing is you're saying, okay, what's the limit as x goes to infinity of this function? Minus 1. If you're going to infinity, does adding or subtracting a constant matter? Not really, because the numbers are getting so big, right? So you can just forget those things, and then you really just have 3x squared over 2x squared. What happens to the x squareds? They cancel, and you're left with... That's a very quick and dirty way to do it. Now, it's not technically correct. It's correct and the answer is correct, but this is what you should do. But we've already done this, so I don't want to do this every time. I want you to just be able to get it and move on. Okay? So if the degrees are the same, it's the leading coefficients. All right? And then the last one that we did in Math 12 is we said if the numerator degree is greater than the denominator, there is no HA. That's what we said in grade 12, Math 12. We said if the numerator had a larger degree than the denominator, so for example, if I had and I said, what's a horizontal asymptote? You would say no horizontal asymptote. And that is true. But there still is an asymptote. Okay? It's called a slant or oblique asymptote, and that's what we're going to calculate right now. So I think Mr. Steed did this, if you were in his class. Okay. So no horizontal asymptote, but there is what's called a slant or oblique asymptote. Okay. So how do you find that? Well, what we're technically doing is we're doing this. The limit as x goes to infinity of this. Okay. Now, asymptote. Oblique? O-B-L-I-Q-U. Sorry. Like an oblique angle. Okay. Slant, S-L-A-N-T. I'm going to show you in a sec here. Oh, okay. Or oblique asymptote. That's what it's called. I'm going to show you what it is in a sec here. All right. Dobie? Oh, I see it. Okay. What operation is happening here? It's division, right? It's division of polynomials. So we're going to divide the polynomials. Now, you have a choice. You can do long division or you can do synthetic division. You can only use synthetic division if the denominator is a linear denominator. Is it a linear denominator? Yes. Does everybody remember synthetic division or long division? Okay, let's do long division because it's more applicable. Okay? So we're doing long division, people, so we're going to divide it. This will be the last thing we do today. Long division. So we go x plus 1 is divided into x squared minus x. Because this is a division, so I'm going to rewrite this is what I'm going to do. I'm going to divide it, yeah? Yeah. You can, but long division is applicable because we might get nonlinear denominators. So I just want to go over long division. What? Huh? Okay. All right. So we ask ourselves, how many times does x go into x squared? X times, right? Like what do I multiply x by to get x squared? X. Okay. I will post a video on how to do long division of polynomials. All right. So x, and then you take that variable there and you multiply it by x, and I get x squared, and you multiply it by 1, and you get x, right? Yes? Yes? Okay. All right. Then you subtract them. X squared minus x squared is no more x squared, 0. Negative x minus x. Negative 2x. And then you ask yourself, how many times does x go into 2x? Or what do I multiply x by to get 2x? Negative 2x. Negative 2. And then you multiply negative 2 times that. Negative 2 times 1 is negative 2. There's a 0 there. We bring down the 0. I'll post a video. Then you subtract them. Negative 2x minus negative 2x is no more 2x's. 0 2x's. 0 minus negative 2. 2. That's your remainder, right? Okay. We're done the division part. Now, do you remember in Math 12, I told you, if you were in my class, I told you you always write it in Math 12 a certain way. We have a divisor D, we have a quotient Q, and we have a remainder R. And we always wrote it as DQ plus R, Dairy Queen plus R, right? In Math 12, we don't write it that way. In this class, what class are we in? Calculus 12. Calculus 12, we write Q plus R over D. Now, Q is your quotient. That's your Q value. What's up there? This is your divisor because it's what you divided by, and that's your remainder. So now, I know this looks like Greek, like totally foreign stuff if you haven't done this before. I say the limit as x goes to infinity of, instead of writing that, I write it as Q plus R over D because they're the same thing. Q, which is x minus 2, plus R over your divisor, which is x plus 1. Okay? Are we good? Are we good? Are we good? We'll go over this on tomorrow, I guess, Wednesday. These are the same thing. Those are the exact same thing. It's like writing 10 over 5 is the same as writing 2. They're the same thing, just in a different form, okay? Now, if I put infinity, like if I don't want to say this. As you go to infinity, I don't know how to say this. If I put in, I'm going to write it like this. Don't worry, this is the only time I'm going to show you all this, okay? So I can break that limit up, right? Because we can break limits up. Yes? Yes. What can you not see? Okay. All right. All I did was break it into this limit and this limit, okay? Yes? Okay. This is the only time I'm going to ask you to do this. This is the reason why you can do the shortcut that I'm going to show you, okay? If I put infinity into this, what happens to this? It becomes 0, right? Because this, if I put infinity, I'm going to get 2 over infinity plus 1, which is really just 2 over infinity, which is 0. So, here's the crux. Here it is. Are you ready? Are you ready? Dylan, are you ready? As x gets bigger and bigger, this gets smaller and smaller. Eventually it goes to 0. So then the graph, or the asymptote, approaches the line x minus 2. This is your slant asymptote. Your quotient, you can't see anymore, your quotient is the slant asymptote. I think that deserves a clap, people. Oh, that's... Thank you. Thank you. Nothing. Okay. This is the slant asymptote. Okay, watch. That's the slant asymptote. This is the last thing. The bell's going to go in 2 seconds. You don't have any homework tonight, so don't worry about this. Just watch. Somebody's going to have to read out the question to me because I'm going to put it on Desmos and you'll see it. Come on. Desmos. What's the function? I forget the function. X squared minus x all over. What is it? X plus 1? Okay. There's the graph, okay? Now watch when I put in x, what was it? X minus 2. When I put in x minus 2, there's your slant asymptote. So you can see here the green part is the graph. As x gets bigger and bigger, where does the green graph get closer and closer to? The line x minus 2. And when it gets smaller and smaller, same thing. That is your slant asymptote. It never gets there, but it gets closer and closer to it. Tomorrow, we got one more little thing to do, and then we'll start putting this all together to sketch curves. You will be able to sketch that curve tomorrow. Well, in a couple of days.